Hey guys, today we are going to review conic sections. So here in our first video we are going to write equations from a graph and then we will graph from an equation. In our next video we will identify conics from their equation and rewrite them in standard form. So here we have an ellipse. The center of this ellipse is at 1, 3. Okay, so for my equation, I'm going to have x minus 1 squared, and that'll be over something. And an ellipse, I need a plus. And then I've got y minus 3 squared over something equals 1. Now that something is going to be the horizontal stretch under the x and the vertical stretch under the y, but then both of them will actually be squared. So the horizontal stretch here is 2, squared is 4. The vertical stretch, 1, 2, 3, 4, squared, is 16. Next I have a hyperbola. This hyperbola happens to be vertical, and because it's vertical, a hyperbola, I have to have the y first, and that's because instead of a plus, we're going to have a minus. When I'm adding, these can be in either order. When I'm subtracting, they cannot be. Horizontal, x first, but this one is vertical, so it will be y first. So the center here is at negative 2, 1. So I've got y minus 1 squared minus x plus 2 squared equals 1. And both of these go over the square of the stretch. So the vertical stretch goes first under the y. That's 2 squared is 4. And the horizontal stretch is 3 squared is 9. Next I have a circle. The circle here has a center of 3, negative 3. So I have x minus 3 squared plus y plus 3 squared equals, now here I've got a horizontal and vertical stretch underneath the horizontal and vertical components. In a circle, the stretch is the same, so I multiply that across to this other side. So the stretch here is 1, 2, 3, 4, squared is 16. Next, I have an ellipse with a center of negative 6, 6. So I have x plus 6 squared plus y minus 6 squared equals 1, and then the square of the stretches will go under these. The horizontal stretch goes under the x. That stretch is 2, squared is 4. The vertical stretch is 1, squared is 1. Now I really could get away without having that here. I could just have y minus 6 squared over nothing, because if I just don't write it as a fraction, it still is over 1. Okay, next I have another ellipse. This one has a center of negative 2, negative 1. So I've got x plus 2 squared plus y plus 1 squared. Okay, so I need to white that out. Alright, it's whited out, so now it actually just says y plus 1 squared. My apologies for the mistake. Don't worry, I'll edit it out before you ever see this. Equals 1. And then over the horizontal stretch, 1, 2, 3, 4, 5, 6, squared is 36. And the vertical stretch, 1, 2, 3, 4, squared is 16. And last, in this row, I have a horizontal hyperbola. Horizontal for a hyperbola means x goes first. I've got a center at negative 2, 1. So I've got x plus 2 squared, and then minus y minus 1 squared equals 1, and then I need the stretches. So the horizontal stretch goes under the x, that is 2, squared is 4. And then the vertical stretch, 1, 2, 3, 4, 5, squared is 25. And then to finish this page, we are going to graph some conic sections. So here we have what appears to be an ellipse. I've got a plus here, but my stretches are different. Okay, so the center of this ellipse is at positive 5, 0. So 5, 0. The horizontal stretch is the square root of 4, which is 2, and the vertical stretch is the square root of 36, which is 6. So for a horizontal stretch, I go left and right 2. For a vertical stretch, I go up 6 and down 6. And here is my ellipse. Okay, not the best ellipse I've ever drawn, but I think you get the picture. Okay, next up we have another ellipse because there's a plus here. Okay, so the center, now we have to be careful, the x is here, so the center has an x component of -4 and a y component of +4. This has a horizontal stretch under the x. The square root of 16 is 4, and the vertical stretch comes from under the y. The square root of 9 is 3. So we have a center at -4, 4, a horizontal stretch of 4, and a vertical stretch of 3. And our last one here, we have a hyperbola. I know that because these are both squared, but I've got a minus. So the center of this hyperbola, and I've got to get the x component first, that's -2, and then the y component is +3. So -2, 3 is the center. The horizontal stretch comes from under the x. The square root of 25 is 5. And the vertical stretch comes from under the y. The square root of 9 is 3. Okay, now from there I'm going to use the horizontal and vertical axes to draw a rectangle. And through that rectangle I am going to draw asymptotes. Okay, now it's vertical, so I'm going to use the top and bottom vertices here, and I'll go from here out toward that asymptote, and I don't want it to curl back in because it will always be getting closer and closer to that asymptote, and then out to the asymptote here on the left, and then on the bottom to the left and to the right.